Hello friends, our today's topic is about VLSM, Variable Length Subnet Mask, and the main concept name is subnetting, and it is the most important topic of your networking. In our last videos we have discussed about LAN and WAN, we have discussed about IPv4, subnet mask, and at last we have discussed about FLSM. In FLSM we know that we need to find our network ID, first and last IP, and after that broadcast ID. But in FLSM there is a problem. What is the problem? Like for example, if I need 300 IP address within one LAN network, then I'm not able to choose C class, because C class subnet mask is 255.0.0.0, sorry, 255.255.0. Okay, so in this, network ID is of 24-bit, but host ID is for 8-bit only, so 2 raised to power 8 means 256 IP address. So I need 300 IP address, so I have to move on into B class. So in B class, 16-bit host means 65536 IP. Now the concept is, like, if I'm taking 300 IP address from this range, 65536 IP address, then 65236 IP addresses are not able to use in any other network. Why? Because the WAN rule is this, that you can choose different network ID with the router. So I have to use all the IP address in one class, but I need only 300 IP address, so I have a big problem about it. To solve the wastage of IP address, that's why we use VLSM, Variable Length Subnet Mask. So the overall concept name is subnetting. So what is subnetting? Subnetting is the process of divide one large network. For example, this is large network. Divide one large network into small subnetworks. Small subnetworks. Like I have to divide this room into two parts, so 2 network will be there, 4 network will be there, 8 network will be there, 16 network will be there. Like I have to divide one exact space into 2 part, 4 part, 8 part, 16 part, 32 part. Okay, let me take an example. So I'm going to start with C class. So I'm taking an example of this 192.168.1.0/24. So this is, I know this is class full network, but I'm going to choose it as a classless network. Okay. So first of all, we need to follow some basic steps in subnetting. So first step is find VLSM. Okay, so 24 means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And after that all zeros. Like all 0 means 8 zeros. So VLSM is 255, 255, 2550. And the value remains this. This is known your magic value. Like we don't need to follow fixed bit. The values remaining is known as magic value. And the third step is block size. The formula of block size is 2556 minus 0 magic value. So I have to minus magic value into 256. Fourth and fifth part is number of networks. Like if we are using this network, what are the number of networks? So I'm using a number of network is 2 raised to power n. N means on bit. So I don't have to choose from already fixed bit. Like in A class 8 bit are fixed, B class 16-bit are fixed, and C class 24-bit are fixed. So I don't have to choose from this. I have to choose from magic number. So how many bits are on? No one is on. So N value is 0, network is 1. Number of host, 2 raised to power H. So H means off bit. So 2 raised to power, all bits are off, 256. So within one network I have 256 IP. Yesterday's video, last videos we have discussed that in one network 256 IP. So I have to find network ID, first IP, last IP and broadcast ID. So what is my network ID? 192.168.1.0. First IP is 192.168.1.1. Last IP is 192.168.1.2 and broadcast ID is 254. This is second IP, this is last IP and this is broadcast ID. So this is the steps that we have to follow in subnetting. Okay, so this was the classful network. Let me take an example of slide 25. Okay, I will write the steps on notepad. Okay, wait. So my first step is find VLSM. So I will write it on this. After that, magic value. This one. Okay, so it will help you to make the video good. And after that magic value, we need to find block size. And after that I have to find number of network, and at last I have to find number of host. And after that we need to find one more thing, valid network, valid host. So this is after this. Okay, so I am taking an example of one number. Okay, so let me take 200.0.0.0 / I'm using 25 here, like one bit is on in this. Okay, so one bit is on, this one. Okay, so what is the VLSM here? I'm taking one space here for understanding you. What is VLSM here? 25 means 255, 255, 255. These are the 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Now 25 means one more bit is on. 25, 26, 27, 28, 29, 30, 31, 32. Okay, so when we do binary to decimal, then this value should be 128. So now this is my subnet mask. This is variable length subnet mask. So now magic value is 128. Block size is 256 minus 128 is equal to 128. Number of network 2 raised to power n, one bit is on. So number of network 2. Number of host are 2 raised to power h, 7 zeros are there. So this is the exact value. Like within two network, 128 IPs. So what I have to find? Network ID, first IP, last IP and broadcast ID. So I have two networks. Okay, the network is 200.0.0.0 and the block size is 128. So 200.0.0.128 is my next network. So in this, first IP should be 200.0.0.1, last IP 126 and broadcast ID is 127. So this is 129 is my first IP, last IP is 254 and broadcast IP is 255. Okay, if we need to find now what is valid network and what is host. So you have seen that first network ID and last broadcast ID is not used in host. Okay, so the valid hosts are 2 raised to power h minus 2. Like if 128 are the host, then valid hosts are 126. And valid network is same as 2 raised to power n minus 2. Like if 2 raised to power n 1. So here we have only two networks. So in this valid networks are 2. So network I have to find like this. Sorry. Valid host I have to find like 128 minus 2. Okay. So if I have 256 IP in one network, then 254 is the valid IP. If 128 IPs are valid, then 126. Like we have to do with minus 2. Okay, let me take an example, another example. Okay, so 25, 26, 27, for example, I am doing for 29. Okay, so what I have to do for 29? Like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26, 27, 28, 29. This one. So VLSM is 255, 255, 255, 248. Because binary to decimal, 2 raised to power 7, 6, this one. 248 is the magic value. Block size formula remains same. Number of network 2 raised to power 5. Number of hosts 2 raised to power 3. Now, how I am easily understanding the concept? Because I am using these values. 5 ones means 5n. 3 zeros means h is equal to 3. 32 network and 8 host. But exactly I am using 30 network here because 0 network I am not going to use. Okay? And after that 200 last network 200 00 248 I am also not going to use. But here I have to work on valid host. So valid hosts are like 6. How? Now 1, 2, 3, 4, 5 up to 32 network I have. First network is 200 000. Block size is 8. 200 008, 16, 24, 32 like this. And after that 1 to 6 is the valid IP, first and last. 7 is your broadcast. 9 to 14 and 15 is your broadcast. 17 to 22, 23. 25 to 30, 31. Like you have to follow the same rule that I have used. Okay, so I will write like if I am going to use all the network, then I am showing you the value, exact value of slash. So when I am using slash 24, okay, then I know that this is class full. 25 class slash 26, 27, 28, 29, 30. So I am going to provide cheat sheet. Okay, here is cheat sheet for you. 255 means easy. 255, 255, 0. Now 25 means 1 bit is on 128. 2 bit is on 128 plus 64 192. Here 128 plus 64 plus 32 224. So you have to solve these R values because in video I can solve only limited values. Okay, so just solve this. 255, 255, 255, 248. This one I have solved just right now, and 252. So exact what you have to see. Okay, in this I have 256 IPs, but when I solve this 128 IP, 64 IP, 32 IP, 16, 8 and 4. These are the total hosts that we are using. So if anybody asks from you like what are the valid hosts, so just do one thing, minus 2, minus 2, minus 2, minus 2, minus 2. So the valid IPs in /30 is 2. So I'm writing with this. So valid IP in this 254, 126, 62, 30, 14, 6 and 2. So with the help of this we can do subnetting. Thank you so much.